In this session, I'm going to describe how cloud is especially useful and convenient for big data processing. I'm going to show how to use big data the cloud way. Some of you may think big data is out of reach. I will show you why it's not the case. Some of you are probably already using it. I'm going to show you how you can get a lot more done for a lot less work. I'm William Vambenepe. I'm a product manager in Google Cloud Platform. When you think about big data, these are some of the things that come to mind. Obviously, there's a lot more than that. But these are the concepts, the tools that come to mind. But if you think about it, none of those are about big data. None of those are about what you're trying to get done. Those are constraints of the tools. Those are limitations. Those are things you have to learn, things you have to deal with. So today, when thinking about how to run big data the cloud way, I'm going to ask you to forget about this. If you don't know about them, don't assume you have to know and master them to use big data efficiently. If you already know about them, take a mental holiday, or take a real holiday, even better, but at least a mental holiday, clear your mind. You don't have to actually forget all of it, but don't assume that these are the starting points for any big data project. Instead, focus on your application. Focus on what you're trying to get done. And focusing on your application really means focusing on the people. So let's pick an example. Let's say that you're building a multiplayer mobile application, a game, where players interact in real life, where they also interact in the game. And that's the application. That's what you're trying to get done. Who are the people who matter? Obviously, first and foremost, your users on the upper left. People trying to just want to use a game and have a good experience, have interesting things happen to them. And then you have developers in charge of building the game. And because this is a game with a lot of player interaction, part of what they have to do is make sure those interactions happen in a way that's meaningful and engaging. Of course, on the flip side, you don't want negative interaction. So you also have to watch for abuse and make sure you police the game. You also have people who have more of a data science angle who want to analyze user engagement models, try to understand what motivates users to come back to the game. What happens if they lose too many challenges, if they win too easily, if they meet friends, if they don't meet friends. How does that impact their tendency to come back to the game? And obviously, you have people with business concern, trying to understand how am I doing? How am I growing? Am I investing in the right marketing channel to bring the right users? Are my users staying with me? And just understanding what the revenue streams are and things like that. So those are the people who matter. And these are the things they're trying to do. None of those people say, I want to work with big data. What they say is, I want to do those things. So let's show how using big data the cloud way, we can make it really easily for those things to happen for these people. Starting with events. Users playing on the game, things happen, events, either implicit or explicit, are emitted. First thing to do is capture the events. And for that, we're introducing today a new cloud service called Cloud PubSub. Cloud PubSub is a reliable, many-to-many asynchronous message delivery system. So just by the name, Cloud PubSub, I assume some of you in the room already know what it does. It's a well-known architectural pattern. It's widely used in some domains. It's very convenient from an architectural perspective. It makes your architecture easy, simple, and also easy to evolve. And yet, it's not used as broadly as you would think because it also comes at a cost. It comes at a cost of relying on an infrastructure to manage that stream of messages, and that can become a signal point of failure, and that can become a bottleneck in your application. So for that reason, that very convenient pattern is not as widely used as it could. Today, with Cloud PubSub, we are taking the burden of running and managing this system for you. So you can benefit from the simplicity of the pattern without paying the cost and the risk of having to manage the infrastructure. Cloud PubSub is a global service delivered and managed by Google. When you start using it, we don't ask you, do you want to be located on the East Coast, on the West Coast? It's one single global entry point supported by Google's global infrastructure. It scales to just what you need. So if you saw the demo at the keynote this morning about Cloud Dataflow, because we had so little time in the keynote, we didn't describe the whole stack. But actually, that demo had Cloud PubSub in the front, ingesting the tweets that were being analyzed. That's the demo about the World Cup. And something like the World Cup, you can imagine when a goal happened, you have just a spike in traffic that goes down. We're not talking a 2-month spike. We're talking like a 2-minute spike. So these are the kind of things that normally you would have to provision for, or you would just be running behind. And when you don't need it, you will be overpaying. Cloud PubSub scales to just what you need. You don't have to manage it, and you pay just what you need. And that's big data the cloud way. So looking into a bit more detail about how you use Cloud PubSub, at the heart of it are topics. Topics are what you define, what you care about. You say, I'm going to create a new topic. Topic has first-class resources. So they have access control lists. So you can give permission to users and application to post to a topic, and give permission to others to subscribe to the topic and read from it. Obviously, I'm not breaking some trade secret by saying that there are computers under the cover, many of them powering that, but they're not your concerns. What you worry about are topic and messages. Cloud PubSub is durable. So if your subscribers are available at the time when the message comes through, it gets immediately delivered to them. If they're not, the messages are safely persisted until they come up and all the subscribers have consumed and acknowledged the messages. Scalable, reliable, with no management. That's the cloud way. It's not just the system itself is resilient. It's that it makes your architecture resilient and resilient to change. So in our example, in the early days of the company, the only thing that matters is having a game that can be played. There is no time for analytics or any other niceties. And yet, you know that there is value in those early events, in those early logs that are coming out. So what you can do is just create a PubSub topic, have all your application clients just post events there, and have a very simple consumer just to write to storage and leave it there. And you can forget about it, and you're safely storing the data. And then, as you mature, as your needs evolve, as you have a bit more breathing room, time comes for you to do something useful with those events. And at that point, you can create an application which is going to register to the topic and consume events. And by doing that, you're not changing anything else. It's a very safe move. You're not breaking anything. You're not modifying anything. On the left side, you don't have to change anything to your publishers. You don't have to update the application and deal with half your users having the new version, half of them having the old version. Or even worse, in some cases, you're publishing from sensors or devices embedded in the field, which are almost impossible to update. No update on the left side. You're not disrupting anything. You're just adding one consumer. And as time goes, as you evolve, it's a very flexible pattern. So you can add more consumers, many consumers to one topic. You can even chain consumers. So for example, you could have one consumer which is trusted to see the raw data coming from the players. And it removes confidential information. It enriches, cleans, filters, any pre-processing. And it can republish to a second topic. And then that second topic can be the one that you open up to your a larger set of users for them to run analytics or other development tasks. So it's, as you evolve over time, as your needs evolve, it's a very powerful architectural pattern. And now we give you the tool that lets you use it safely. So we've been talking about applications without saying much about what they are. What are those applications that consume events from Cloud PubSub? Well, they can be anything, really. It can be an application on Google Compute Engine. It could be an application on Google App Engine. It could be an application on this laptop. It could be in your data center. It's a very open and versatile service you can consume from anywhere. Today, for the purpose of this session, we're going to focus on one special case, one special kind of consumers, which is data processing pipeline. Because remember, what we really want is to allow developers to focus on the application, not on the infrastructure. And in our example, many of the use cases, what they call for is a data processing pipeline. So looking on the upper right, managing user interactions. So making sure that users who are in the same team, in the same location, who have similar objectives, can find one another and play together. Detecting abuse, making sure people aren't harassing one another, analyzing user engagement, all those things are best expressed as data processing pipeline. And that's why we're introducing today another service, which you saw in the keynote this morning, Google Cloud Dataflow. Google Cloud Dataflow is the right tool for data processing pipeline. It lets you write your processing pipeline as one simple Java program. The initial version is Java. The service itself is actually language agnostic, but the first SDK is a Java one. And then you let Google deal with everything that's needed to run that processing pipeline, with all deployment, monitoring, tuning, configuration tasks. As Urs mentioned this morning, this is what has replaced MapReduce at Google. It's actually third generation. There's a complex family tree of data processing products at Google. This is replacing the service which replaced MapReduce at Google. So this is something that, even though it's a new cloud service, it's a very mature data processing tool that we've been using internally. So let's find out a bit more about what it does. This is your application, in many cases, like in our example, a constant stream of events that happening into the system, in our case, going through Cloud PubSub. In many cases, this is the shape in which you want to consume them. You want to handle them in real time as they come through. Because remember, we're talking about user interaction. It's not very useful if I get a notification at 4 a.m. telling me, last afternoon, you and 2 team members were in the same location. You could have mounted an operation together or something like that. It's too late. Same thing with abuse. If you find people who are harassing others, or somebody reverse engineer your client, and they're playing programmatically in the game and creating havoc, if you find them 24 hours later, they've had hours to make others miserable, and those users are not coming back. So in those cases, you want to analyze on the fly right away and take action right away. And that's why Cloud Dataflow supports running in streaming mode. In that mode, we let you tell us how you want events grouped and aggregated. We make that happen for you. We call them buckets. We let you tell us if you want things bucketized, by session ID for web traffic, by time window, either fixed window or sliding window. In the case of the game, probably by team, by location. You tell us how you want events aggregated. We make sure that those buckets are created for you, that your application logic is processed on the content, and as new events come in and as older events age out, we take care of keeping the processing always fresh and up to date. There are other cases where you want to run against historical data. So taking the example of user engagement models. When trying to understand how your user behave and react to things happening in the game, you want to benefit from weeks, months, years of historical information where you've seen them act. And so for that, Cloud Dataflow lets you run your pipeline in batch mode and go against all this historical data. And the interesting thing is that it's actually the same program which is running in batch mode and in streaming mode. The changes are very minute. There are some changes to how some of the I/O operates to switch from reading files or tables to reading streams, both input and output. And then you configure your bucket. Other than that, the actual logic, the actual algorithm that you're running is the exact same in both cases. And that's very powerful. That means that in the case of the user engagement model, once you have created your model about how users react, you can take the same model and run it in streaming mode. So you can see in real time, as you adjust parameters of the game, or as new users come. You may have a marketing campaign that brings a new kind of users. As those things change, you can see how your user behavior compares to what you expect, and you can make adjustments on the fly. Another use case for which you'd want to run the same pipeline in batch and stream is the case where you make changes to your pricing algorithm. So you've been pricing events as they occur, and then you realize you have a bug or you have an idea for a new feature, just additional insight that you're trying to extract. At that point, you can change your pipeline, and all the new events will get processed with the new algorithm. But the old ones aren't comparable anymore. What you'd like to do is reprocess them. And that's where running the same pipeline in streaming mode and in batch mode is very useful, because you get to reprocess as much as your historical data as you want. And of course, because you're in the cloud, you have capacity available to do that. You don't have to worry about taking capacity away from supporting new events in order to manage the reprocessing. You just get what you need. That is big data the cloud way. So I mentioned, and Urs said earlier, this product is based on 10 years of parallel data processing research at Google. And when I say research, I mean in a very applied way. Pretty much all the Google products you use every day are based on these technologies. So even though it's a new cloud product, there is a lot of maturity internally. And that maturity doesn't just show up in the capabilities, in the APIs that we expose to you. A lot of it is under the cover. It's in our ability to take your processing pipeline, which is expressed in a very simple, intuitive way, and turn that into a processing pipeline, which is very efficient to execute. And then, as we execute the pipeline on your behalf, we take care of all the work that you shouldn't have to take care about, to worry about. Starting machines, starting the right number of machines, monitoring, tuning, babysitting in cases where some workers have a problem restarting work. All that is done for you, by us, in an optimized way. There's a session in this same room tomorrow at 10 a.m., which is dedicated entirely to Cloud Dataflow. Shows you a lot more detail. We'll show you some code as well. So please come back here at 10 a.m. and you'll find out a lot more about how it works. One of the things with those highly optimized systems is that it's really hard to know what's going on. So if everything goes well, you're happy. As soon as you're trying to understand what's happening, either because there's a problem, and there's a bug in your code, or there's a bottleneck that you're trying to eliminate by writing your code differently, then you're left with the task of assembling all the logs, finding them, and trying to make sense of them. Even once you found all the logs and brought them, they're expressed in many cases in terms of the optimized execution plan, which makes no sense to you. That's not the code you wrote. So for Cloud Dataflow, we've made sure not only to collect all the relevant logs and metrics for you and present them, but to do that in a way that matches directly to the way you have defined your pipeline. So every step, every task described here corresponds to a line of code in your code that you recognize. It's understandable, and it's actionable. So these are the two new products that we are introducing today, Cloud PubSub in limited preview, and Cloud Dataflow currently in private beta. What about this green cylinder? It represents all the cloud storage services at Google, of which there are many. Today, I'm going to focus specifically on one of them, BigQuery. That's the one that's the most relevant for large-scale data analytics. So unlike Cloud Dataflow and PubSub, BigQuery is not a new service. It's been out for a couple of years. Some of you, I'm sure, know about it. Some of you use it. You may not be aware of the latest improvement, though. For those who are not familiar with BigQuery, it's a large-scale SQL-based analytics engine. You bring your data, and then you send queries that we execute on the data you've brought. So once again, it's a fully managed service. You're not responsible for deploying, tuning, managing a cluster. The storage is handled separately from the processing. So if you store data and do not query it, that's perfectly fine. You don't have to pay for an unused cluster, which is just sitting around to store data. You only pay for storage at the same rate as Google Cloud Storage. When you want to process, you have an engine at your disposal, which is capable of processing terabytes of data in seconds and gives you an interactive experience for real-time analytics. That difference, that flexibility in the model between storage and consumption, it becomes very clear in cases such as public data sets. So some of you may have heard just last week, some data was released from New York City around all the taxi cab rides in 2013. I think about a bit under 200 million taxi cab rides, and pretty detailed data, including starting point, ending point, price, tip, time of the day. That was released, and somebody just put it in BigQuery as a public data set. If that happened anywhere else, and you wanted to use that, you would have to say, well, thank you for the data. Let me set up a cluster. Let me import your data. And then I can work, and by that point, I've paid already a couple hours of cluster processing time. With BigQuery, all you have to do is go to the web console, enter a SQL query, and in seconds, you get your results. And you can find out that December is the month where tips are the highest on average, maybe not very surprising. In seconds, you're in business, and you're only paying for that query or the queries that you decide to run. And by the way, the first terabyte of queries is free every month. So going into more detail into BigQuery, especially for those of you who have used the product but may not have seen all the recent announcements, It supports a very rich and flexible ingestion model. So there is streaming ingestion. That's what Dataflow uses. When Dataflow processes events and puts them into BigQuery, it happens with the streaming API. Obviously, you can load files in batch mode. If you use Google Analytics Premium, we have an integration where we can take your unsampled user clicks data from Google Analytics Premium and put that for you directly in BigQuery. So that data is available for you to analyze any way you want. You can bring additional data and join it with CRM data, marketing data, third-party demographic data, whatever you want. The data is yours, easily accessible in BigQuery. We've also partners with many other companies who provide additional sources of information, like social network information, and also companies who provide tools like ETL tools to simplify bringing data into BigQuery. So that's on the ingestion side. On the consumption side, it's also a very flexible service with many ways to consume data. For example, you can consume data from Cloud Dataflow, as we saw earlier, or from Hadoop, which we'll discuss later. And to support that, BigQuery allows data to be made available in parallel to many workers at the same time. There's also a simple table read API. If you use Python, you can use the pandas library, for example. There's ODBC support. But obviously, out of all of those, the most popular way to use data in BigQuery is via the BigQuery engine itself, that powerful SQL engine I described earlier. And it's not just SQL. In addition to that, the engine has a lot of additional support for more modern data processing tasks, for more big data kind of tasks. So for example, it supports nested records. It lets you query inside JSON object. If you have JSON object stored in your database, you can query inside of them during the query. It supports view, it supports regular expressions, and coming soon, we will have support for user-defined functions in JavaScript. So here's our business user. In addition to BigQuery, which gives him or her interactive access using a dashboard to a large amount of historical information, either a dashboard that they did themselves or a dashboard from our many partners like Tableau and Qlik and Beam Analytics and others who've created commercial dashboard with great visualization on top of BigQuery. In addition to that interactive view of historical information, thanks to Dataflow working in streaming mode, the business user can also get a real-time view of how things are going right now. So which are my top 5 most popular games right now? What's my rate of new users joining the game? What's my attrition rate? All those can be calculated in real time and also presented for a full real-time and historical business view. And obviously, BigQuery is not just for business analytics. That's just one example. It can also be used by developers. Today, a lot of developers use Hive, for example, for data processing of structured data in SQL. BigQuery can be used as a development tool to do just that, except much faster and without any overhead or management complexity. And that's big data the cloud way. So I mentioned other storage services on cloud platform. I'm not going to go into details of any of them, but they're Google Cloud Storage for Object Store, Cloud Data Store, our managed NoSQL, and Cloud SQL, a managed MySQL solution. They're not specific to analytics use cases, obviously, but they are well integrated in the platform and can play a role there too. Let's say your developer has decided she wants to use Pig to ingest data. I have some ETL pipeline for which that's the right tool. Or maybe your data scientist wants to run machine learning algorithm using a library for Spark. Or he or she wants to do real-time Scala analytics using Spark. Those are the right tool for the job. Those are available on Google Cloud Platform, and those can be made to run the cloud way as well. So what does it mean to run open source software like Hadoop and Spark the cloud way? Well, first thing, Hadoop runs great on Google Cloud Platform because of the quality and the consistency of the VMs, of the network, and of the storage. It runs really efficiently on the platform, and you can have a traditional deployment. And when it comes to HDFS, you have a choice. There are 3 different block storage services appropriate for HDFS. You can use the traditional persistent disk backed by spinning disk. You can use the SSD-backed persistent disk, which just went generally available today. Or you can use the newly announced local SSD, which was announced today and is now available in Trusted Tester. So you have 3 different services, 3 different performance characteristics at 3 different price points available to you depending on your needs. But you don't actually even need to set up HDFS. We've created 3 connectors to Google storage services, one for Google Cloud Storage, one for BigQuery, one for Data Store. These connectors implement Hadoop native API, such that your code in Hadoop, your MapReduce, your Pig, your Hive, if you use Hadoop streaming in other languages, or Spark, because Spark uses the same I/O interfaces as Hadoop, your user code in Spark or Hadoop can run entirely unchanged and access data directly in cloud storage, in BigQuery, in Data Store. That means that the data is not locked in silos into one cluster. You can have several Hadoop clusters working against the same data, and you can also have BigQuery working against it. You can have Cloud Dataflow working against it. The data is not locked into a specific pricing engine. It's available for all. And so those are available, all 3 of them. The GCS connector is actually open source on GitHub. The other 2, we haven't done that yet, but the plan is to make them widely available and open source for everybody to make it very easy. Architecturally, it makes it very easy now because you don't have to worry about when you're spinning a cluster, copying data into it, and then making sure that you save the data back before you turn it off. You can use those connectors in conjunction with HDFS, or you can use without HDFS. This is really as you see fit, as you prefer. In addition to the connectors, we have also created a tool called BDUtil, which stands for Big Data Util. That tool automates the deployment and the configuration of Hadoop and Spark on Google Cloud Platform. So we'll deploy them, we'll spin the VM, as many as you want, we'll deploy, we'll configure, including installing and configuring the connectors, and the cluster is available for you to use. So if you take that level of automation, if you add to that the connectors that give immediate access to the data as soon as the cluster is up, if you add the fast boot up time of the VMs on Google Compute Engine, and the fact that you pay by the minute, all those things together really give you a tool set that allows a much more flexible and dynamic way to run Hadoop clusters in Google Cloud Platform. And that's how you can run Hadoop and Spark and other open source tools the cloud way on Google Cloud Platform. So as we describe the services of the platform and how together they can help users focus on the task they're trying to achieve, not focus on setting up and managing infrastructure. As we describe that, we come with that somewhat complex picture. So let's simplify it a little bit. At the end, the heart of it is 3 fully managed cloud services, which do one thing, do it really well, and make you really productive. Cloud PubSub for event handling, Cloud Dataflow for data processing pipeline, either in stream mode or in batch mode, BigQuery for large-scale analytics, and then the ability to integrate and bring the best of the open source ecosystem and to have those open source tools work in a manner that's well integrated with the platform, such that you don't have to choose to be in one world or the other. You can mix and match as you see fit and have all those services work together. And we see that in practice. We have customers who already have set up big data clusters on-premise or on some IaaS cloud, and they can bring that as is to Google Cloud Platform to benefit from the cloud consumption model, the quality of the infrastructure, the cost, the scalability. They can bring it with no modification. And then, as they see fit, if they want to, opportunistically, they can decide to use BigQuery or Dataflow or PubSub to lower their emission burden and for the task where they think that's the right tool. And vice versa. Going back to our example of a new company, at that stage in the life cycle, what companies value most is velocity. The last thing they want is to spend time worrying about infrastructure and configuration. And so the fully managed services are by far the most productive way to get started and to build an entire platform. And it's not just the easy tool to get started, because the scale is there. These are the tools that can carry you up to the larger scale that you will need. That being said, they don't do everything. They don't try to do everything. There are tasks for which PubSub, Dataflow, and BigQuery are not the right tool. And for that, there is a rich ecosystem of open source tools which we make sure can run well integrated into Google Cloud Platform. And that's the overall choice that we want to give you, and that's how we want to put you in control and let you decide how you want to run big data the cloud way. More information coming up in this room. This is the right place to be. 10 a.m. tomorrow, the dawn of fast data. This is a session specifically on Dataflow. 4 p.m. also here tomorrow, predicting the future with Google Cloud Platform, which will show you how to use BigQuery and Dataflow for a concrete practical example. And then we have many developers and PMs at the sandbox talking about those various topics, as well as on the cloud booth on the floor. So please come and see us there, and we'd like to discuss your use cases and how these tools would apply to you. And finally, thank you for coming here in San Francisco. Some of you have traveled a lot. We're coming to you as well. We will have cloud roadshows, hopefully to a city close to yours. So please check out this URL and see when they'll be available and when we're coming to you. If you want more information about Cloud Dataflow, we have set up a Google group where you can register to be informed of new announcements for the product. And Cloud PubSub is now available on the website. The documentation is there. It's a limited preview. So if you're interested in joining, there is a form where you can put your information and request an invitation to the limited preview. Thank you very much.